Good evening, ladies and gentlemen. I'm Leonard Westrups, and tonight we delve into the world of genetically modified organisms, or GMOs. These organisms have been scientifically altered in a laboratory to enhance desired traits such as resistance to pests, drought, or to improve nutritional content. But what are the implications of this technology? Join us as we explore the controversy surrounding GMOs and their impact on our food, health, and environment. Let's now listen the interview of our correspondent Patrick from Chasklops University. Thank you, Leonard. I'm here with Professor Preston Garbis. Let's begin to understand what GMOs actually are.
Sure thing. Let's dive deeper into the realm of genetically modified organisms. Imagine DNA as the blueprint of life, containing all the instructions for an organism's growth, development, and function. Scientists can manipulate this genetic code by inserting, deleting, or modifying specific genes to achieve desired traits in an organism. For example, a gene responsible for pest resistance in a certain plant can be transferred to another plant species to confer the same trait, reducing the needs for chemical pesticides. This process, known as genetic engineering, allows for the precise alteration of an organism's genetic makeup, resulting in traits that may not have occurred naturally through traditional breeding methods. The potential benefits of GMOs are vast, ranging from increased crop yields and enhanced nutritional content to improve resistance to diseases and environmental stresses. However, concerns have been raised regarding the safety of consuming genetically modified foods, potential environmental impacts, and socio-economic implications for farmers and food security. As researchers continue to study and debate the implications of GMOs, it's crucial to weigh the benefits against the risks and ensure that rigorous testing and regulatory measures are in place to safeguard human health and the environment.
Thank you. After this excellent theoretical introduction, we will watch what farmers think about this. Back to you, Jonathan.
Hey, hi Tom. What are you doing today?
I'm preparing the field for the new season. In fact, a couple years ago, I began to cultivate GMO crops.
Okay, but now we want to know what are the main benefits and drawbacks of GMOs.
After I switched to GMOs, one major difference I've noticed is the reduced need for pesticide. With GMO crops engineered for pest resistance, I've been able to significantly cut down on chemical inputs, which not only save me money, but also reduce my exposure to harmful chemicals. Another advantage is improved crop yields. The GMO varieties I cultivate are engineered to withstand drought and other environmental stresses, allowing me to produce more food even in challenging conditions. This has been a game changer for my farm's productivity and profitability. As you can see, I now produce same amount of food in half the space. The remaining field can now be rewilded to increase biodiversity. However, there are also drawbacks to GMOs. One concern is the potential for cross-contamination with non-GMOs crops, which can affect organic farmers and compromise the integrity of their products. Additionally, there is the issue of seed ownership and dependence on biotech companies, which can limit farmers' autonomy and perpetuate inequalities in agricultural sector. Overall, while GMOs have brought undeniable benefits to my farm in terms of pest resistance and yields improvement, I remain cautious and mindful on the potential risk and ethical consideration associated with their use.
Thank you very much.
Thank you.
Wow, this was really interesting. But before arriving in the farm, how are GMOs created? We asked this question to a group of researchers from the International Institute of GMO Research of Norbury.
Creating a genetically modified organism, GMO, involves several complex processes and procedures. First, researchers identify the desired trait they want to introduce or modify in the target organism, whether it's increased resistance to pests, tolerance to herbicides or enhanced nutritional content. Next, they isolate the specific gene responsible for the desired trait from another organism, which could be a different plant species, a bacterium, or even a virus. This gene is then inserted into the genome of the target organism using a variety of techniques, such as gene guns, bacterial vectors, or viral vectors. Once the gene is successfully integrated into the target organism's DNA, scientists employ various methods to ensure its expression and functionality. These may involve regulatory sequences to control when and where the gene is active, as well as genetic markers to track its presence in subsequent generations.
Then, throughout the process, rigorous testing and analysis are conducted to assess the safety, efficacy, and stability of the genetically modified organism. This includes laboratory experiments, field trials, and environmental risk assessments to evaluate potential impacts on human health, biodiversity, and ecosystems. Finally, regulatory approval from the government agencies is required before the GMO can be commercialized and released into the market. This involves comprehensive reviews of the scientific data, risk assessments, and adherence to safety protocols to ensure that the GMO meets regulatory standards and poses no undue risks to human health or the environment. Well, thank you to these three incredible researchers. Joining us today is Franklin Sorbel, Professor of Bioregulations at the Landrisburg Institute of Law.
Hello.
Now let's shed some light on the legal framework surrounding GMOs in Europe. Can you walk us through the key regulations governing GMOs in the European Union?
Certainly. In the EU, GMOs are subject to strict regulation aimed at ensuring their safety for human health and the environment. The main legislation governing GMOs is the Directive 2001/18/EC, which established the regulatory framework for the deliberate release of GMOs into the environment.
Okay. And what specific requirements does this directive impose on the approval and marketing of GMOs?
Yes, it outlines a comprehensive procedure for the authorization of GMOs, including risk assessments, monitoring, and labeling requirements. Before a GMO can be placed on the market, it must undergo a rigorous safety assessment to evaluate its potential risk to human health and the environment.
And how does the EU handle the labeling of GMO products to inform customers?
The EU has stringent labeling requirements for a GMO products to ensure transparency and consumer choice. Any food or feed containing GMOs above a certain threshold must be labeled as such, allowing consumers to make informed decisions about the product they purchase.
And thank you very much for providing us with insight into the European regulations governing GMOs. It's clear that ensuring safety and transparency are top priorities in the EU approach to this complex issue.
Thank you.
Thank you. Before we conclude, let's take a quick look at some statistics regarding the top producers of genetically modified organisms globally. As of recent data, the United States leads the pack, accounting for the majority of the world's GMO production, followed by Brazil and Argentina. Together, these three countries dominate the market for GMO crops, with significant implications for global agriculture and food systems. This was our weekly scientific inquiry. Thank you for your attention. Good night from Leonard Westrops.